Hey guys, how's it going? Hope you're all doing well still. I hope you liked the first video I posted. Please let me know what you're thinking. But this is your second one for math this week, and I just want to reteach you tangents because we touched on it a little bit before you guys went on a break, but I want to do it again. So I'll do two examples with you, then you guys can work on your own. And then that's it for circle geometry. So we'll start with an easy one and then work our way harder. So for the first one says, for number one, it says find the value or find V and find W. Now V and W are both angles, as we can tell, because we need to find them in degrees. Now, just going to let you take a look at it for a second. And then if you notice, we have a tangent line and we have the radius. Now the radius obviously makes what when it intersects the point of tangency. So when it intersects the point of tangency, it creates a 90-degree angle. Okay, so again, only on the point of tangency. This isn't 90, this isn't 90, and it touches the tangent line right at the point of tangency. And from here, it's pretty easy. We know that the sum of the angles in a triangle add up to 180. So because they add up to 180, then I know that 90 plus 60 plus 30 will give me 180. And then if I look at the other triangle, this is 32. I know this angle is also 90 degrees. Wow, there we go, 90 degrees. So if this one's 90, this one's 32, then this one has to be 58 because then their sum of the angles add up to 180. Okay, so that's as easy as it can get. I'm going to need some room for question number 2, so I'm just going to let you look at that for a second, and then I'm going to erase it. If I can find where I put the eraser. Right here. Okay, so question number 2. We are going to find x. So take a look what you've got and let's go from here. So I can see that I have a line that is tangent. How do I know that it's tangent? Because it intersects the circle at only one point. And we have the radius that is connected to that point of tangency. And we know that when the radius connects to the point of tangency, it creates a 90-degree angle. So I know that's a right angle triangle. Yeah, I know this kind of doesn't make it look like a triangle, but it is. So bear with me. Okay, now we got to find x. Now x is just this little piece right here. But, I mean, don't you think I should find this whole piece here before finding this little piece? So I'm going to find this whole piece right here. All right, so to do so, we are going to use what? Yeah, I really hope you guys are saying Pythagorean theorem. Okay, so we're going to use a squared plus b squared equals c squared. Okay, so again, these are both my short sides. I know my longest side, which is c, is across my right angle. So I don't know what c is. I know, remember, it doesn't matter what you put in for a and b. Just want to make sure you guys can read that. I should have thought I have a calculator on hand, but I'll get one right now. Okay, so, wow, it's squared. All right, so 22 squared is 484, and then 28 squared is 784 equals c squared. I really hope you guys remember how to use Pythagorean theorem. You all seem to do pretty good with it, so I think you'll be fine. If I add these two together, get 1268 equals c squared. And remember, I'm not done. I got to get c by itself. So I need to square root both sides to get c by itself. You know what I just realized is my calculator There we go. All right, square root. So if I take the square root of this, I get 35. I'm going to round to the nearest tenth. 35.6 equals C. So if I take a look here, I just figured out that from here to here, so this length is 35.6 centimeters. Now if that's 35.6, how do I find x? Well, if you did not notice, this, so from here to here is my radius. So it's actually 28. So if this here is 28 and from here to here it's 35.6, I need to subtract the two to figure out what x is. So x ends up being, so if I write this down here, hope you guys can see that, 35.6 minus 28 equals 7.6 is x. So that is your final answer. And that's it.